This is Geometry 8.3. We're talking about special right triangles. Today we're going to talk about the 45, 45, 90 triangles. So what we've learned in the past is about Pythagorean theorem. When we're trying to solve for a side in Pythagorean theorem, we have a right triangle and we would know two sides. In these examples down here, we have a right triangle, but we only know one side each time. Now, each of these can probably be solved using the Pythagorean theorem, and we'll talk about that as we get closer. If we were to use this with the Pythagorean theorem, I'll write it on a separate sheet of paper. If we were to use the Pythagorean theorem, what they're trying to imply with these tick marks is that these two sides are the same length. If these two sides are the same length, then these two angles have to be the same. If this is 90, then these two angles have to both be 45. That's the only way it can add up to 180. So this is a 45, 45, 90 triangle. If one of the sides, one of the legs is 12, we automatically know the other leg is 12. Now you have two sides and you can use the Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. And the hypotenuse is across from the right triangle, right angle. So the hypotenuses are unknown. Our legs are 12. So our hypotenuse squared is going to be 144 plus 144. That's 288. Now, what do we do to get rid of the square of the hypotenuse? You need to take the square root. Now, 288 was made up of 144 twice. So that's 2 times 144. You know the square root of 144 because that's 12. So you have 12 root 2 as your hypotenuse. And I will tell you, this is not a coincidence. All right? Let's try the next one using Pythagorean theorem. If this is 45 degrees and this one's 90 degrees, then you know the missing angle has to help you add up to 180. So it has to be 45 degrees. So this is a 45, 45, 90 triangle. The hypotenuse is 6 root 2. Since your two angles are the same, you know your two legs are going to be the same. That's kind of the trick. So we could, if we wanted to, we could use Pythagorean theorem. It is possible. The hypotenuse is 6 root 2, and we're squaring that. The legs are both x, so we're x squared and x squared. So we have 2x squared. How do we square 6 root 2? You square the 6 and you square the root 2. So you square the 6 to get 36. You square the root 2. What is root 2 times root 2? Root 2 times root 2 is 2. So this actually comes out to be 72. And we take the division of both sides where we get x squared equals 36. And how do we figure out what x is? Take the square root of both sides, and it is 6. That is not a coincidence. What do you see as the pattern? Those are 6s. This is root 2. Those were 12s. This is with the root 2. It's just a pattern. The hypotenuse is root 2 times the leg. We just found a pattern that's true about every 45, 45, 90 triangle. So we're going to come down here and we're going to say that as long as we have a 45, 45, 90 triangle, the hypotenuse is root 2 times each leg. So here it is. X and X in a 45, 45, 90 triangle will have a hypotenuse that is that value times root 2. So the extended ratio, like we've talked about before, would be 1 to 1. That's what this would mean. They're this exact same. To root 2. 1 to 1 to root 2. Because they're going to multiply each one of those values by that constant number to fill in the blanks. So here's your magical formula. Hypotenuse equals leg times root 2. So when we come down here, we don't have to do all of this Pythagorean theorem work. There is a shortcut. If you focus on the hypotenuse equals the leg times root 2, this is your leg. You know it's going to be the same as this one. Here's your hypotenuse. The hypotenuse is the leg, which is 12, times root 2. And you get 12 root 2. It's almost like you didn't show any work. But you wrote a formula down. Be sure to write the formula. Let's try this again. You always know the hypotenuse, not squared, the hypotenuse equals the leg times root 2. It has to be a 45, 45, 90 triangle. This time, take a look. This time the hypotenuse is 6 root 2. We're trying to figure out this unknown. We know those unknowns are exactly the same. We'll call those x. Notice I'm not squaring anything right here. How am I going to get the x by itself? What's with the x? The root 2. So we're going to get rid of this square root of 2. And how do you get rid of it? You do not subtract it. You divide it. So when you divide it, the root 2's cancel out. And you're left with x. What's going to happen on this side? The root 2's will cancel out, and you're left with just 6. So the legs are 6, and the hypotenuse is the leg times root 2. It works the pattern perfectly. And then you get into these questions. This is a little bit more complicated. This doesn't have a root 2 on the hypotenuse. Because it's a right triangle and the two legs are the same length, you know it's a 45, 45, 90. So you know what the pattern's going to be. The hypotenuse is going to equal the leg times root 2. Well, I know my hypotenuse is 10. My leg, if you want to call it x, that's fine. You can call it leg. You can call it x. How are we going to get to the x? What do we have to move away from the x? The root 2. So I'm going to do that through division. I divide my root 2 out of there. And that leaves me 10 divided by root 2. How do I simplify 10 divided by root 2? Can I call it 5 root 2? No, they're not the same type of number. So I have to rationalize the denominator. What we learned last week. Rationalize, you have to multiply the top and the bottom by this root 2. That gives you 10 root 2, because those multiply together. What does the bottom give you? Gives you just a 2. It does not cross out. The answer is not 10 root 2. Root 2 times root 2 gives you 2. Now you might say the answer is 10 root 2 over 2. What is half of 10 root 2? 5 root 2. So 5 root 2 and 5 root 2. You can divide only the type of numbers that are the same type. You see, these are both non-radicals, so I can divide the non-radicals. Over here, I was able to divide just the radicals because they were both radicals. Let's try this one last time. I notice this is a 90-degree triangle, and one of the angles is 45. So to make 180, I know the other angle has to be 45. So this is a 45, 45, 90 triangle. So I know my formula is hypotenuse equals the leg times root 2. My hypotenuse is 12. My legs are unknown. So I need to solve for the x. How would I solve for x? You have to divide by root 2. And that gets my x by itself. How am I going to simplify this? If you have 12 divided by root 2, what do you have to do? Can I call that 6? Can I call that 6 root 2? Yeah. Well, maybe, but you need to know what you're doing to get there. We're going to rationalize the denominator. That gives me 12 root 2. What's my denominator? Root 2 times root 2 is 2. I can reduce my 12 and the 2. And yes, that is 6 root 2. So you have your formula. Hypotenuse equals the leg times root 2. And that only works for a 45, 45, 90 triangle.